Hi, I'm Darren and welcome to Level Up Double E Lab. Well, I just got back from Hamvention 2025 and I picked up several items that are likely to make very interesting projects here on my channel, and I thought I'd have a little fun with a big reveal of them. Let's check them out. I had a really good time at this year's Hamvention. I got to see a lot of cool old and new stuff and got to talk amateur radio with a bunch of my fellow hams. Now, I wasn't able to make it last year, so being able to get back to Dayton this year was extra special for me. Now, several other YouTubers do a really good job covering Hamvention in detail, so I'm just going to mention briefly a couple of my favorites. At the top of my list, there's the flea market. It just cannot be beat in terms of size. The sheer volume of stories to hear and share about the variety of radio gear is almost as fun as finding a few bargains. Of course, all that walking, talking, and shopping makes a ham hungry, so another favorite of mine is the variety of food. Yeah, it's mostly carnival fare, but where else can you get a pork tenderloin sandwich the size of a catcher's mitt? Yum, I had mine with lots of mustard and pickles. I also changed my itinerary this year. I went on Friday and Saturday instead of going on Saturday and Sunday like I have the past two times. And that worked out so much better because I had 2 full days at Hamvention and got to sit on some more forums than I usually did and got to see more things. All right, let's get down to it. So item number 1 is a Tektronix CFG 250 signal generator. Let's start with taking a closer look at the front panel on the CFG 250. And I do need to get a manual offline and study it because I don't know all of its features and specs, but it's pretty clear. It's a up to 2 megahertz function generator, so kind of sort of into low RF frequency. It's got a variable adjustable frequency within each of these settings here. It looks like adjustable sweep rate, adjustable sweep width, all pretty standard. Of course, it's got sine, triangle, and square wave output. What's interesting is it's got adjustable DC offset, adjustable duty cycle. It's got 2 ranges of voltage, 0 to 2 volts peak to peak and 0 to 20 volts peak to peak. So that's interesting that it would go that high. Overall condition, it's not bad. I paid $30 for this. I thought that was a reasonable price. It was part of a collection of about, I think the seller, the ham that was selling these had 2 or 3 of these and 3 or 4 Tektronix triple output power supplies from the same era. I don't need or didn't need a power supply, but didn't have the sweep function generator, so definitely just went with it and skipped on the power supply. Around back, another interesting feature, it looks like it's got adjustable AC input, US, European, and a couple other voltages here as well, just by setting these switches. VCF input, not sure what that is, but again, I'll go study the manuals and figure out what that does. It's a little dirty, but not bad. Easy to clean it up. The bottom is in decent shape. Still has all 4 rubber feet on it. The handle's not broken or cracked, so that's another good feature. There is some discoloration on this edge right here. It almost looks like there was something larger that was sitting on it for a long period of time, and this side of the plastic sort of the yellow versus the rest of it. Or maybe it's just dirt. I can clean it. I'll find out pretty quickly when I do go to clean it. All right, so before I power it up, I want to open it up and have a look on the inside and see if there's anything to be concerned about. Okay, I've taken the bottom cover off and I'm just doing a quick visual inspection. I did not expect to find any surprises, and I'm not seeing any surprises. Things like the electrolyte caps still look to be visually okay. They're not bulged, they're not leaking. They could still be bad. They could still need replacement, but there's not any obvious giveaways that they've completely failed. And there's a few others scattered around the board in various locations, and they also look okay. There's a couple of fuses hiding down there. I will check those with an ohmmeter before I apply any power to it. And another thing that looks interesting is a lot of adjustment points on here. So clearly there's some things to do if you're going to calibrate it. I'm not going to touch that, obviously, right now. But what I think I'm going to do is put the cover back on, hook it up to my dim bulb tester, apply some AC power, and then hook the output up to the scope and check it out. Okay, I've got the CFG 250 powered up, connected to my scope in the background. And also I've got the output teed off the scope input to just a set of speakers here. Because as I'm demonstrating it, I think a lot of what a sweep generator does is easier to hear than it is to see. And lingering in the background, I've got my dim bulb tester. I did power it up on it first to make sure that there were no issues. And I've shown that so many times on my channel, I decided not to repeat it. So just want to do a quick check out here and see how well the CFG 250 is working. And like I say, audio sometimes is better than video here. So let me turn this up a bit and start playing around with the amplitude and the sweep width. Sweep rate. Ooh, can make all kinds of science fiction noises. Very cool. Frequency. Let's try a square wave. Triangle. And back to sine. Very cool. And higher frequency. Ooh. No, it's above 10 kilohertz. I can barely hear that. Bring that down. So yeah, kind of a, I guess, fun demonstration here, but clearly the CFG 250 appears to be working just fine. The 250 fills a gap on my test bench. I didn't have a sweep function generator. Of course, you don't need one for every project, but when you need one, you gotta have one. All right, let's move on to item number 2, which is a Sencore FE149 analog multimeter. I got the FE149 on the workbench so we can take a closer look at it. And I really didn't know anything about this particular model before I bought it. I only paid $10 for it. I just could not pass it up. The seller, unfortunately, didn't know any history on it, unfortunately. So this one doesn't come with a story. I did do a quick lookup online shortly after I got home, and it does seem to be one of the earliest solid-state meters using field effect transistors. Hence, it's a FET voltmeter or FET multimeter, and it's got 99 ranges and has FET accuracy, of course. This is really cool, by the way, to have this tag still on it. Talks about 15 megohm input resistance, so that's pretty darn good. So surpassing any vacuum tube voltmeter of the era, I would guess. And apparently it can run off of AC power or with a battery pack plugged in. So 99 ranges, and it had a special price of $169. Apparently it was $20 cheaper, but got marked up, not marked down. So that's kind of cool. Glad this came with it. And then this tag at the top is interesting also. I know this is not going to show up on camera very well, but it talks about using a special procedure to plug the unit in and let the electrolytics charge up and condition for a half an hour if you haven't used it recently. So clearly they added this later, maybe because of some problem with the electrolytics not holding up well over time. But lots of large push buttons here on the front for all the various functions. It does have these leads built into it, which is kind of inconvenient. I mean, obviously we're used to just plugging any leads we want into a modern meter, but this one they're permanently attached, so maybe there's something special about them. But let's spin it around for a couple other things here on the back. I noticed unfortunately it has this weird, or I should say probably not very common, 3-prong cord. So one of the things I'll definitely want to look at, because I don't have this cord, is to see how much tear up it might be to put in a standard modern 3-pin jack and still have it look good. And the other thing I wanted to do here real quick, because I'm not going to get into a full teardown on this guy, is pop off this battery door, which looks like it's going to come off real easy, and just make sure there's no corrosion left over in there from a leaky battery. That's always a risk with these older meters. Try to get this on camera. Looks like it's a standard, D cell would snap in there. Spare fuse, but not much corrosion. There's a little bit there on that contact, but I'm not seeing any on the cover and not any down in here. So maybe this guy might be in pretty good shape. I can kind of peek in there and see the circuit board, but I'm also not really seeing an easy way to take the case apart at this point. So I'm going to save the further disassembly for a episode just about it. Now, unlike with the 250, I did not buy the Send core to fill any particular need on my test bench over there. I've already got plenty of analog and digital meters that do all the same functions and do them quite well. I went with eye candy here. I wanted to have this guy as soon as I saw it because I think it'd be really cool on future projects to have an enormous analog display to show some particular function or troubleshooting that I'm trying to demonstrate on a project. Okay, item number 3 is this guy, and this is definitely the long shot of everything that I bought this year, and it is a Heathkit IP20 power supply. Let's take a closer look at the IP20. Now, I did get a little bit of a story about this guy. I bought it from Charles, and he was cleaning out a stash of projects, and apparently this one had been sitting around for a while, and he thought it might have been one that was left over from years ago when he bought several of them just to get enough parts to be able to restore one. And he was very honest that it's a parts unit. As we'll see in a moment when I pop the case off of it, it's been extensively modified, but the transformer, he said, is still good, and the meter is still good. So those are good bones to start with to try to make, a functional version again. Like the Send core, I didn't know anything about it before I bought it. $10. How could I turn it down? Because I think it could make a really cool project if I can get it to work again. Its features are kind of unique. It's got 2 controls for the voltage range and 2 controls for the current. There's like a coarse setting here to set the voltage in 5-volt increments, and then a fine control to adjust in between the 2 coarse settings. And then you can current limit it too, from 50 milliamps all the way up to 1.5 amps. And again, you can set a limit on that as well. It's kind of beat up. There's no severe or really heavy mechanical damage to it. It's obviously accumulated some dust and grime over the years, but that doesn't scare me. The meter, does wiggle back and forth, so it's not frozen. I'll definitely confirm before I get deep into the project that it's okay, and also confirm that the transformer is okay. This would be a unique addition to my bench. I have nothing like this right now. My 2718 in the background doesn't go up anywhere near to 50 volts. So that would be nice to have that additional headroom on some of my projects. But we'll see. I'll pop this case off and you'll see just how much work I'm going to be in for here. And like a lot of these Heathkits from this era, it makes sense to put them on their face on something soft, like a towel. I already took the screws out. There are only 3 of them. And then you just lift the case straight up. Of course, you got to tuck the cord down in there. And look at what we got. It's actually kind of clean here on the inside. There's the transformer, obviously. And as far as extensively modified, I don't think this was standard Heathkit instruction to have 2 transistors flopping out in space like that. There are quite a few wires coming out of the transformer. The way this works, you actually select right at the secondary what voltage range that you want for the rest of the rectifier stages. So that's kind of unique. So in other words, you don't start with 50 volts and knock it all the way down to 1 volt. You'd start with a AC coming out of the secondary, much closer to what you're trying to get to. But that makes for obviously a lot of wires and a really complicated switch deck down here. So that's one area that could be a little dicey to see what shape it's in. And then over here on this side, we got a big heat sink and 3 more power transistors. So plenty of room in here to try something different. So I'm not quite sure what I'll do with this yet. I mean, there's lots of options. I could try to fix it up with parts that get it back to original, or I could strip all of this out and put in a modern electronic circuit that'll do variable voltage control and current control. We'll see. It should make for a fun project if the meter actually works, and of course if the transformer still actually works. If I do manage to get this IP20 to work again, it will be an accomplishment right up there with me restoring the DX60 and the HW101. Okay, so sticking with the Heathkit family, item number 4 is a bit simpler. I have here a VX1 electronic voice control. It looks like so many other pieces of Heathkit ham gear from that era. It's a small gray box with a few knobs on the front panel, some wires sticking out the back, and a terminal strip. So what is it? What does it do? Well, it's a Vox controller. Vox meaning voice-operated transmission. Now, most early ham stations had a separate receiver and a separate transmitter, and changing between receive and transmit required manually switching over each time you switched modes. In some cases, you might have 2 or more things to switch in sequence, so it would become quite tedious when you're trying to, say, work a contest. A lot of switching back and forth, and you didn't want to get out of sequence there. So the Vox controller helps automate some of that by reacting when you start speaking into your mic, and it'll send a signal to an external antenna relay that'll send a signal to mute your receiver and engage your transmitter. And the controls on the front fine-tune the Vox action. And then those connections on the back would go to your transmitter and your receiver and your antenna relay. This time delay would adjust how many milliseconds from when you stop speaking would the receiver come back on. You can control the Vox working or not working with this control. The receiver would help you set so that the audio coming from the speaker of your receiver wouldn't trip the Vox. And then, of course, this one would set to your normal speaking volume to actually engage the Vox control. On the back, let's take a quick look at something of interest here. These 2 points are marked 110 volt AC. Now, I would not be the least bit surprised that is live line voltage to go to an antenna relay. That would be common back in that era. So certainly not something we would accept from a safety standpoint nowadays to have live AC exposed in the back of some device. So a little bit of a story on this. I bought it from Jeff for $10, another $10 purchase, and it did have a brief story behind it. It comes from an estate of a ham who recently passed away. Now, unfortunately, that's a common occurrence nowadays. He had a relative, apparently, who worked for Heathkit back in the day and was able to occasionally get him many items over the years, some of which were apparently returns that didn't need much repair to make functional. So he's able to build an impressive Heathkit collection that way over the years. So let's take a quick look inside. I already took out 3 of the 4 screws. I'll just pop one out. And just like I did with the power supply, it's easiest to put it on its face and pull the case straight up around all of the connectors. You can see, maybe I'll leave it like that. Try to get the light on it. It appears to be mostly original. It's got some vintage dirt on it too, so that's really cool. Let's flip it over and look on the back, or turn it around, I guess. Sliding this cable around. Maybe I should just do this. Very awkward. Try to get a look here. So that's a selenium rectifier. There's another suspect cap up there, but that's probably all original too. So not bad. It doesn't look like it's been hacked or modified, and other than needing a cleaning, an alignment, a few caps replacement, maybe replacing the selenium rectifier, and of course the big electrolytic, can't forget this guy right here is going to be suspect. I think it shouldn't take much to get this guy usable again. I did a quick bit of research, and adapting this VX1 to work with my DX60 is not as simple as just plugging it in. Even though this has an octal cable and that has an octal accessory jack, the pinouts don't match at all. It's very clear that this was not intended to work with that. But functionality, I think it can be made to work, so I'm going to have to look at doing some rewiring, maybe making an adapter cable, and hopefully nothing more complicated than that. And I don't need to use it with the HW101 because it has Vox built in already. Okay, last but definitely not least is something kind of unique, but if I'm able to make a project out of this, I think it'll be very useful, and it is an HP programmable step attenuator. There's no story on this item. It was just another $10 bargain. It was in a bin with about half a dozen more of the exact same things and some other switches, and it's highly likely all that stuff came from some salvaged spectrum analyzers. It has two SMA connectors on it and a pigtail harness coming off. It says 24 volts DC right there, if that can show up on camera. 24 volts DC, 0 to 70 dB, 0 to 4 gigahertz. So it's a mystery at the moment of what's going on inside. I'll need to do some more internet research before I tear it down, or at least delicately open it up and see what's inside of it. Going to try to reverse engineer what each wire does, and the whole goal of this is to see if I can turn it into a standalone digitally controlled step attenuator. So it would be a nice accessory for the lab, and it'd be an upgrade from this guy, which is a manual step attenuator that I made a year or so ago, and it's very simple. It's just a network of pi pads on here with surface mount resistors. So this would be an upgrade to this if I can get it to work. But if I can't figure it out, well, it was only $10. I did end up with a nice variety of projects to keep me busy for at least a couple of months, or until the next local Hamfest happens to come up. Sometimes I'll run across a whopper of a project like the HW101, or sometimes it's like this. It's a collection of smaller things. In closing, I would ask if any of you guys have ever worked on any of these pieces of equipment or restored any of these items and have run across any gotchas or tips you'd like to share with me. Please do leave a comment. I'd love to hear what you have to say. As always, I hope you're enjoying the content here on my channel. So until next time, bye for now.